In this chapter, we are going to talk about how to create a database and how to populate the database with given items. But of course, first of all, we have to talk about the given data types because we have to define the given types whenever we create a given variable. So first of all, let's talk about character data. Characters can be stored as fixed length or variable length strings. As far as the fixed length strings are concerned, it always consumes the same number of bytes, and this is the so-called char. As far as variable length strings or varchars are concerned, the number of bytes can change. So this is the crucial difference between chars and varchars. Chars are fixed length strings, varchars on the other hand are variable length strings. So when we create a char, then the maximum length for char is 255 bytes. For example, when we want to store country codes with 3 letters, then we have to create a char with value 3, and it is going to be quite efficient because we know for certain that every single country will be represented with 3 characters. So this is why we have to use a fixed length string. For example, HUN stands for Hungary, USA stands for the United States of America, GER stands for Germany, and so on. So in these cases, when we know the length of the strings we have to store, then it is advisable to use chars. And of course, we can use varchars. The maximum length for varchar is 64 kilobytes. For example, we can store names with varchar because the length of the names will differ. Of course, we don't know for certain that what's going to be the length of a given name. I mean that how many characters are there in a given name. Of course, there are names with just a few characters. There are very long names. So in these cases, we have to use variable length strings. For example, varchar 20 means that we can store strings up to 20 bytes. But of course, if the given string is just 4 bytes, then we will use 4 bytes exclusively. So that's the difference between fixed length and variable length strings. Okay, what if we would like to store a huge text? So if we want to store a huge text, then using varchar is not the best option possible because this is what we have been talking about, that we can store up to 64 kilobytes. But what if we would like to store text that exceeds 64 kilobytes? In this case, we have several options. We can use tiny text, text, medium text, and long text. And this is the case when dealing with WordPress related websites. So for example, these texts and these images are stored in a MySQL database. So of course, in this case, I have very small text, as you can see. So these are the texts WordPress has to store in a MySQL database. But of course, it may happen that for a blog article, we have to store tens of thousands of words in a given database. And of course, this is when we can use the text type. So as far as tiny text is concerned, the maximum number of bytes is equals to 255. The text is very similar to a varchar because we can store up to 64 kilobytes of data. The medium text is approximately 60 million bytes of data, and the long text can store up to approximately 4 billion bytes of data. Okay, so of course, again, it depends what we want to store. If we want to store just a very small text, then of course, maybe tiny text is the best option. If we have a huge blog article with tens of thousands of words, then of course, we have to use medium text or even long text. Okay, what about numerical data? There are several different numerical data types depending what range we are looking for. Of course, we can use signed and we can use unsigned values. Unsigned values when we know for certain that the values are greater than or equals to 0. So as you can see, for example, tinyInt can store up to 256 possible values. Of course, if we are after negative values as well, then the range will be -127 up to 127. If we know for certain that we don't have to store negative values, for example, if we want to store the age parameters of given employees, then of course we know for certain that the age parameter is greater than 0. In this case, we can use an unsigned tiny integer because of course we know for certain that the age parameter of a given person is within the range 0 up to 255. Okay, then we have the small integer, again signed and unsigned, so we can store values up to 65,535. If we want to store larger values, then we have the medium int, then we have the int or the integer, and then we have the big integer. Of course, if we want to store the wealth, so the net worth of a given person, then of course we have to use big integer, because if we consider Elon Musk or Jeff Bezos, of course they have hundreds of billions of dollars, so we have no other option but to use big integer in order to represent their wealth in dollars. Okay, so this is why it is crucial to know about the numerical data types, because it depends on the concrete application. If we want to store the age parameter, then of course we don't have to create big integer, because the tiny integer will be fine as well. If we want to store the salary, then we have to make sure that we can represent every single salary for sure. So in this case, the integer or the big integer will be the best option possible. Okay, what about floating point numbers? So what if we would like to store values such as 2.71828 and so on? In these cases, we can use float, we can use double, or we can use decimal. The float or the floating point number is a single precision number represented on 4 bytes, while double is a double precision number represented on 8 bytes. Of course, we have two parameters p and s. The p stands for precision. It is the total number of allowable digits both to the left and to the right of the decimal point. What about the scale or the size? It is the number of allowable digits to the right of the decimal point. So here we have the decimal point and we have 1, 2, 3, 4, 5 digits on the right side of the decimal point in this case, and we have a single digit on the left side of the decimal point in this case. So we can define what kind of values we would like to store with float, double, or decimal. And of course, it is again absolutely crucial. For example, we have created a simulation for the solar system. So we have used differential equations and we have used the so-called Runge-Kutta approach in order to solve these differential equations. And we have been using floating point numbers. And we came to the conclusion that some things went terribly wrong because the simulation didn't work. And then we came to the conclusion that instead of floating point numbers, we have to use double precision numbers in order to represent the given positions and the given velocity parameters, and we ended up with the valid solution. So again, it is absolutely crucial to know what data type to use, whether it is a floating point number, a double, or a decimal. We are going to talk about several examples and it is going to be clear. And finally, we have to consider date and time. So there are several types as well. We have the date, as you can see, year, month, and the day itself. Then we have the date time, so we have the year, month, day, we have the hour, we have the minutes, and we have the seconds. We have a timestamp variable, then of course we can define the year exclusively, and we have the so-called time with which we can define the time exclusively, hours, minutes, and seconds, as you can see. So again, it is absolutely crucial to know what to use, because sometimes we are after the date format and sometimes we are after a time format and so on. So that's all about the most crucial data types. In the coming lectures, we are going to talk about how to create database tables and how to define the data types for the given variables. Thanks for watching. In the previous lectures, we have been talking about how to install MySQL server. We have been talking about the fundamental basics as far as databases, database management systems such as MySQL, and database languages such as SQL are concerned. So these are the topics we have already considered in the previous chapter. And in this chapter, we are going to focus on the programming language itself. So as far as the MySQL workbench is concerned, I have already created a MySQL connection, as you can see, with name Udemy test, but of course you can create as many connections as you want. For example, I can use another connection, for example, test, and it is going to work fine. The host name, the port are going to have the default values 127.00.1. This is the local host. The port is the default value 3306. It is going to work just fine. The username is the root and you can test the connection. successfully made the MySQL connection. So this is how you can create a new connection. I am not going to create it because I have already created the Udemy test connection. So if you click on that given connection, that this is where we are going to create our SQL related statements. So first of all, we can show the databases that's already present in MySQL. So if we type in show databases and we execute the statement, then as you can see, MySQL Workbench is going to show us the available databases. These are the default databases. So I haven't created any databases so far. These are the built-in databases: information scheme, MySQL, performance scheme, and so on. What we are after is that we would like to create our own database. So this is what we have been talking about in the previous lecture, that the database is a set of persistent data used by a given application. So first of all, we have to create the database itself, and then we can create as many tables associated with the given database as we want. So this is, for example, a database table, and we are going to create tables like this. Okay, so first of all, we have to create a database with name Udemy. So if we execute the statement, then as you can see, it is going to work just fine. We have created the database with name Udemy. Okay, so if we call the show databases command and execute it, then we can check whether we have created Udemy or not. And as you can see, Udemy as a database have been created. So what do we have to do? First of all, we have to use a given database, because otherwise MySQL is not going to know whether we are dealing with information scheme database, the MySQL database, the system database, or Udemy database. So we have to use the use keyword, so use the database Udemy. Okay, so as you can see, after executing the statement, it is working fine. Now we are dealing with the Udemy related database. So what do we have to do? We can create as many tables associated with the Udemy database as we want. And this is exactly what we are going to talk about in the next lecture. In the previous lecture, we have been talking about how to create a database. We have been talking about how to use an underlying database. And in this lecture, we are going to talk about how to create a given table in that given database. So what do we have to do? We have to use the create table statement. Then of course we have to define the name of that given table. So for example, student. Then we can use multiple lines and spacing to make sure that it is human readable, that what are we doing exactly. So of course we can use a single line statement and it is going to be just fine. It is going to be interpreted by MySQL, but of course we would like to make sure that it is human readable. So it is straightforward for us humans what's happening under the hood. In this case, we create a table named student, and of course we have to define the given columns. So for example, we will have a student ID, we will have a name, we will have a gender, an age parameter, and so on. So first of all, we have a student ID. It is going to be an integer, but this is exactly what we have been talking about, that we don't have to create an integer. We can use a small integer instead and unsigned, because of course we know for certain that IDs starts with 1, 2, 3, 4, and so on. So we don't have to deal with negative values. So in this case, we will use small integer, which means that we can store up to 65,535 students, because of course IDs are going to be unique integers. So we are going to identify every single student based on a given unique ID. Okay, then we have the name of the student. So student name, for example, it is going to be a varchar. This is what we have been talking about, the variable length characters. For example, 30. Okay, then we have a so-called gender. In this case, we are going to represent the gender with a single character, whether it is a male, capital M, or female, capital F. In the coming lectures, we are going to talk about enum types, and it is going to be a bit more convenient to use enums. In this case, just for demonstration purposes, a single character is going to represent the gender itself. And that's it. In this case, a given student will have a student ID, a student name, and the given gender. So if we execute the given statement, so let's execute it. As you can see, create table student has been executed. So what does it mean? If we show the tables and we execute the statement, then as you can see in the Udemy database, we have a single table, the so-called student. Okay, we would like to describe the student table. So if we do something like this, then as you can see, this is exactly what we have created. There are three fields: the student ID, the student name, and the gender. We have the types. It is an unsigned small integer. The student name is a varchar. The gender is a single character, and all of them can have null values. Okay, so as you can see, the default values are null values. And what does it mean exactly? That whenever we create the student table, we can define that we would like to make sure that it is not a null. What does it mean? For example, if we say that the student name is not a null, then in this case, we have to define a name for that given student, which means that if we want to insert a given student into the student database table without defining the student name, then we are not able to execute that given statement because we have defined not null, which means that no matter what, we have to define the name of the student. Just for demonstration purposes, we have used something like this. So the default values are null values. So basically, we don't have to define any of these values. And in the next lecture, we are going to take a look how to insert a given value into a database table. Thanks for watching. In the previous lectures, we have been talking about how to create a student table with these variables, the student ID, the student name, and the gender. And in this lecture, we are going to talk about how to insert given values. So what do we have to do? We have to insert into the database table called student, and we can specify the given values. The first value for the ID, then we have the name, for example, Joe Smith, and then we have to define the gender. Let's take a look what's going to happen if we use something like this. We have been talking about that the gender is a single character, whether it is a male or a female, so a capital M or a capital F. So what's going to happen if we try to insert a given string with multiple characters? If we try to execute the statement, there's going to be an error because we are not able to insert 4 characters into a variable that can store only a single character. But what's going to happen if we try to insert M stands for male? Then it is going to work fine, as you can see. So this is the first way of inserting given values. So we insert into and we define the database table, and then we define the values. Of course, it is going to be a bit better programming practice if we define the given variables. So we know for certain that we will insert the student ID. So basically, what do we have to do? We have to enumerate the column names. So we have the student ID, then we have the student name, and finally, we have the gender. And why is it good? Because now we know for certain that the first parameter is the student ID, the second parameter is the student name, the third parameter is the gender. So if we execute this statement like this, of course, sorry for that, value 2, let's use something like this. The name will be Anna, and for example, Smith is going to be just fine, and it is female. So what's going to happen? If we execute the given statement, then as you can see, it is working fine. We are able to insert values if we define the given column names as well. And it is a bit better because if we have multiple values, then it is not straightforward at what's happening under the hood. So what are these parameters? Okay, what if we would like to insert, for example, another student without specifying the name? So if we have something like this, that we do not specify the student name, the ID is 3, the gender is equals to female, let's see what's going to happen. Is it possible to execute that given statement? Yeah, it is possible to execute that given statement because we have defined the student database table like this. So if we call the description student table and we execute the statement, then we can take a look at whether is it possible to insert null values or not. And as you can see, we are able to insert null values. So what's going to happen? Basically, the values we do not specify are going to be null values. So we are going to talk about the select statement, but of course we have to take a look at the content of the database table. So with the help of select star from the student, we can get all the items from a given database table. So we are going to talk about this select keyword in the coming lectures. Now we have to check whether it is working fine or not. By the way, sometimes we can omit the semicolon at the end of the statement and sometimes we do not. So the best programming practice is to use the semicolon at the end of every single statement. So if we rerun the statement, and as you can see, it is working fine. And what's happening? As you can see, we have managed to insert Joe Smith with student ID 1, we have managed to insert Anna Smith with student ID 2, and we have managed to insert the third student with student ID 3 without the student name, because this is how we have defined the database table, that it allows null values as well. Anyways, we are going to talk about how to make sure that a given column cannot store null values. What's crucial that we are able to insert given entities, given students into a database table. So in the next lecture, we are going to talk about how to update a given row and how to remove a given row from a database table. Thanks for watching. In the previous lecture, we have been talking about how to insert a single item into a given database related table, but of course it is not that convenient to insert the items one by one. So a good question, is there a way to insert multiple items with the same query? Of course. So we can insert into the student database table as far as the values are concerned, and here we can define the given values. For example, with student ID 1, the student name is equals to Adam and it is a male, of course. And then we have to use a comma and we can insert multiple items. ID is equals to 2, the name is equals to Joe, and of course it is a male as well. So we have to insert items one by one. For example, we have index 7, we have name Anna, it is a female. Then we have the index 8, the name is equals to Frida, the gender is equals to female, of course. And if we run this query, then as you can see, it is working fine. So if we select everything from the student database table, then let's see what's going to be the result. As you can see, we have inserted the items Adam, Joe, Anna, and Frida without any problem. So this is how we can insert multiple items with the same SQL statement. Thanks for watching. In this lecture, we are going to talk about how to remove a given entity from a database table. So in this case, we have just 2 items in the database table. So first of all, let's insert multiple items. And the second crucial point we have to make is that let's click on Edit, then Preferences. Okay, and as far as SQL editor is concerned, let's make sure that the save update is unchecked, because otherwise MySQL Workbench has the tendency to prevent these updates and remove operations. Okay, I have already unchecked that given tick box. So let's insert into the student database table as far as values are concerned. For example, 3 with Adam and gender is equals to male. So let's insert it. Okay, then let's insert 4 with Joe, it is a male as well. Then let's insert with index 5, for example, Michael, it is a male as well. Then we have Lincoln with index 6. Then we have the index 9, I guess, just to make sure that it is not going to clash with existing IDs. We have the Angelina, it is a female, of course. Okay, and we have, for example, Fiona with index 10. So if we insert multiple items, we can select everything from the student database table. Okay. If we use something like this, then of course there are several items: Anna Smith, Lily, Adam, Joe, Michael, Lincoln, Angelina, and Fiona, both males and females. So if we want to delete, we have to specify the database table we want to manipulate, and of course we have to specify a given condition. So of course we are going to remove a given item based on the student ID, the student name, or the gender. So we have to define one of the columns of the given database table. So for example, when the student ID is equals to 2, so what's going to happen? This is the database language, and the database server, so MySQL, is going to process this statement, and it will come to the conclusion that, okay, I have to manipulate the student database table, and I have to remove the given row where the student ID is the column, as you can see, is equals to 2. So if we run this query, okay, for some extremely strange reason, MySQL didn't execute this statement for the first time, but anyways, so this is how we can remove a given entity. So if we select star from students database table and run the query, as you can see, we have removed the student with student ID 2. Of course, we are able to remove multiple items from the database table. For example, we would like to delete from the student database table. Okay, let's make sure that the syntax is valid. So where the gender is equals to male. What does it mean? That MySQL is going to take a look at the items in the database table and going to remove every single row where the gender is equals to male. Let's remove the females because there are fewer females. So there are 3 females. So if we execute that given line and we select star from student database table, then as you can see, the females have been removed from the database table. Of course, we can use so-called Boolean values. So for example, we would like to delete from the student database table where the student ID is greater than 3, for example, and the student ID is smaller than 6. Then what's going to happen? Of course, MySQL is going to consider all the student IDs within this range, so that are greater than 3 and smaller than 6. We have 4 and 5, and it is going to remove all the rows from the database where the student ID is either 4 or 5. So if we execute this given command, okay, it is working fine. So if we select star from the student database table, then as you can see, the students have been removed with index 4 and 5. So this is how we can remove a single item or multiple items from a database table. Thanks for watching. In this lecture, we are going to talk about how to update existing entries in a database table. So basically existing rows. So what do we have to do? We have to use the update keyword. We would like to update the student database table, and we would like to set, for example, just for demonstration purposes, the student name to be equals to test. And of course, we have to define a given condition. So where the student ID is equals to 3, for example, of course, in the where statement, we should define some unique values. For example, the primary key. We are going to talk about the primary keys in the coming lectures. What's crucial that we have to use a given entity that can identify a given row in the database table uniquely. So in this case, we update the student database table and we set the student name to be test where the student ID is equals to 3. Okay, so if we run the query, then it is going to work just fine. So what does it mean? That if we select everything from the student database table, then as you can see, we have updated the student name to be test where the student ID is equals to 3. So we have to be very careful with the update statement, because if we update the student database table and set the student name to be equals to something like this, just for demonstration purposes, where the gender is equals to male, then of course what's going to happen? MySQL is going to check every single row of the database table where the gender is equals to capital M, so male basically, and update the student name accordingly. So there's going to be multiple updates. So if we run the query and check the table, so select star from student, if we run this query, then of course you can see that the student names have been updated to something. So this is why usually we use the primary key, in this case the student ID, that can identify the given row or entity uniquely. So this is how we can update a given value in a database table. Thanks for watching. In this lecture, we are going to talk about how to update the structure of the database table. So in software engineering, it is quite common that the model of the application has changed, and of course this change must be reflected in the database as well. So far, we have been dealing with students with three parameters: the student ID, the student name, and the gender of the given student. But what if we have to update this database table and we need an additional column, for example, the name of the university? Of course, the first solution would be to delete the whole database table and create a new table with the updated columns. But of course, the problem is that the data present in the actual database table would be lost forever. So what do we have to do? We have to modify the existing database table with the help of the alter keyword. So we have to alter the database table called student. We have to add an additional column with name university, and we can define the parameters. For example, it is going to be a varchar and not null. So what does it mean? That we have to define the university whenever we insert a new item into the database table, and it is going to be a variable length string. Okay, so if we use something like this and we run the query, it is working fine. So what does it mean? If we select star from student as the database table, then of course it is working fine. So as you can see, we have an additional column, the so-called university, and of course we can update the given table. What do we have to do? We have to update the table student. We have to set the university to be equals to MIT, where the student ID, so student ID is greater than 0. So what's going to happen? The database management system is going to check the student IDs, and because all of the student IDs are greater than 0, it is going to update the university column value to be MIT. So if we run the application, then of course it is not going to work fine because there's a typo, university, something like this. Okay, and if we select star from student, then of course it is going to work just fine, as you can see. First of all, we have managed to create another column as far as the student database table is concerned, and we have managed to update the values. Okay, so this is how we can add an additional column, but what if we have to get rid of a given column from an existing database table? We can use again the alter student as the database table. We have the drop column, or in MySQL we can define drop, and we have to define the name of the given column, so university. And of course, sorry for that, we have to define that we alter the given database table named student. So if we do something like this and then we select everything from the student database table, then we can come to the conclusion that the university column has been removed. So this is how we can add an additional column, and this is how we can remove a given column from a database table. Thanks for watching. Hi. In this lecture, we are going to talk about how to drop a database table. Why do we need it? Because sometimes the requirements may change, and for example, there may be a database table that's unnecessary, and of course we are able to get rid of it without any problem. So we are able to get rid of a database table with the help of drop. We just have to drop the given table with the name student. So what does it mean? It's quite straightforward that we would like to get rid of the database table with the name student. And if we run this SQL query, we are not able to use that given database table with student name. So if we select star from student, there's going to be an error that table student doesn't exist. So I would like to show the tables within the test database, and okay, because we have the S, tables in test is empty, so we have managed to get rid of the student table. So it's very important to make sure that you are not going to use this drop table statement, because you can get rid of whole database tables within milliseconds. So it is quite a dangerous operation. By the way, we are able to drop the database itself. Okay, so we just have to specify that we drop the database with the name test, and if we run it, okay, basically we have managed to get rid of the database table with the name test. So if we would like to use the database with the name test, of course there's going to be an error because unknown database test. Why? Of course, because we have managed to get rid of it. So this is how we are able to get rid of database tables, and this is how we are able to get rid of databases. Okay, thanks for watching. In this lecture, we are going to talk about primary keys. So first of all, what are primary keys? A primary key is a column or a set of columns that uniquely identifies each row in a given database table. By the way, usually keys are called indices, and these indices have something to do what we have already discussed in one of the previous lectures as far as b and b plus trees are concerned. So this is how we can achieve logarithmic running time complexity. But anyways, in this lecture we are going to talk about how to use primary keys, and then in another chapter we are going to talk about how to boost performance with the help of indices and primary keys. So why is it so crucial to define these indices? Okay, so what's crucial that we can define primary keys that can uniquely identify every single row in a database table. So a primary key must be unique. If there are multiple primary keys, then the combination of the columns must be unique. So we can define a given primary key based on multiple columns. But of course, in this case, the combination of the two columns must be unique. So primary keys must be unique. The second crucial criteria is that primary keys cannot have null values. So the not null constraint is added implicitly. What's extremely crucial that a table can have only one primary key. Okay, we have discussed that we can construct a primary key based on multiple columns, but it is going to be a single primary key. So this is why we can come to the conclusion that a table can have only one primary key. And if we do not specify a primary key explicitly, then MySQL generates a hidden primary key for us. So primary keys can be generated automatically despite the fact that we have not created any primary key. Okay, so in the previous lectures we have created the student database with a student ID, a student name and a gender. And what do we have to do if we want to create a primary key in a database table that has already been created? Of course, we can use the alter statement. So alter table student, and we have the odd primary key, and we have to define the column which we want to transform into a primary key. So we can define multiple columns, this is what we have been talking about, but usually we use integer values such as IDs. So if we use the student ID as a primary key, then we have to do something like this. So if we save and run it, then as you can see, the SQL query has been executed without any issue, and we can call the description of the student database table. So if we do something like this, then the student ID is going to be the primary key. So as you can see, we have an additional parameter whether the given column is a primary key or not. So as you can see, we have managed to transform the student ID into a primary key. Of course, whenever we create a database table with name, for example, employee, then what do we have to do? We can define, for example, the ID, and in this case, we have to make sure that it is going to be a primary key. And if we use the primary key, then we don't have to define not null, because primary keys are not null by default. Okay, so for example, it's going to be an integer, and this ID in the employee database table is going to be the primary key. Of course, we can define the name as a varchar, so we have varchar 30. So if we execute the show tables query, then as you can see, we have an employee database table. We have a student and we have an employee. So if we use the describe and we define the employee, something like this, and run the application, then as you can see, we have managed to create the employee table with 3 columns: the ID, the employee name, and the age. And as you can see, we have managed to create the primary key as far as the ID is concerned. And of course, if we want to get rid of this primary key, so for example, we come to the conclusion that we don't need a primary key as far as the employee table is concerned, what do we have to do? We have to use the alter table as far as the employee is concerned, and we have to drop the primary key. So if we use something like this and execute the query, as you can see, there has been no issues. So if we describe the employee table, so describe the employee table and run the query, then as you can see, we have removed the primary key. So the ID is an integer with no null values. So it has the not null feature without a primary key. So there is no primary key as far as the employee database table is concerned. So in one of the coming chapters, we are going to talk about the fundamental basics as far as the primary key is concerned and how to boost the running time of a given database with the help of the B-tree data structure, with the help of the B+tree structure, but it is going to be a bit more complicated. So first of all, let's understand the fundamental basics, and then we are going to understand the very deep concepts behind databases. So this is how we can handle primary keys. Thanks for watching. So far so good. We have been talking almost every important operations as far as table manipulation is concerned in SQL. In this lecture, we are going to talk about the auto increment feature of primary keys. So we have the student database table. So if we run this query, then we have 3 columns: the student ID, the student name, and the gender. And first of all, I would like to drop the table student because I would like to recreate that table. So we drop the table student. It is going to work fine, which means that if we want to describe the student as a database table, then of course there's going to be an error. The table udemy.student doesn't exist. So let's create table with name student. And what do we have to do? Of course, we can define the parameters, so the columns one by one. For example, we will have a student ID. In this case, just for demonstration purposes, we use ID. It is going to be an integer. It is going to be a primary key, and it is going to be auto increment. So auto increment. If we use something like this, then this is how we notify MySQL that, okay, this ID as the column will be an integer as far as the data type is concerned. It is going to be a primary key, so an index, and it is going to be auto incremented. So what does it mean? That we don't have to specify the ID explicitly. MySQL is going to use the next integer possible whenever we insert a given value. So we are going to take a look how it works exactly. So we have a student name as a varchar with 30. We have an age parameter with tiny integer. Okay, and that's all about this student table. So let's run the query, and it is working fine. So if we describe the student table, then what's going to happen? Of course, we will have 3 columns. The ID, that is an integer, it cannot have null values because it is a primary key, and primary keys cannot have null values, and it is auto-incremented. We have another parameter, the student name, and finally we have age as the third column, so the third parameter as far as a student is concerned. So let's insert values. We would like to insert into student, and let's define the values one by one. We would like to insert, and here we don't have to specify the IDs explicitly because we have the auto increment feature. So we can define the student name, for example Adam, and the age is equals to 23. Then we have another student, Kevin, the age is equals to 21. Then we have, for example, Anna with the age parameter 27. Then we have Joe, for example, with age parameter 19. And if we use something like this, of course we have a problem because now we have to define that we are going to insert the student name and the age parameters. So if we rerun the query, then as you can see, it is working fine. So if we take a look and select everything from the student database table and run the query, then as you can see, despite the fact that we haven't defined the IDs, because it is an auto-incremented primary key, MySQL handled all the values. So Adam has the ID 1, Kevin has the ID 2, Anna has the ID 3, Joe has the ID 4, and so on. So we don't have to bother with auto-incremented integer values, and this is quite convenient because usually we use IDs as primary keys, and of course primary keys are incremented by 1, so we can use the auto-increment feature, which is quite convenient. So this is how we can use the auto-increment feature combined with primary keys. Thanks for watching. In this lecture, we are going to talk about how to handle categorical data with the help of enums or enumerations. So we can define the so-called enum as a variable type, and we can define the categorical values such as male or female or something like this. So in this case, we have 2 categorical data, male and female accordingly. So first of all, let's drop the table student because I would like to recreate that given table. Okay, so let's create the table student, and what do we have to do? We have to create an ID. It is an integer primary key and auto increment. Okay, then we have a given name as a varchar. And finally, we have a given gender. Sorry for that, the student name. So student name, because the name variable is a variable associated with MySQL. So let's use student name. And we have a gender as enum with male and female values. So these are the possible categorical values for the gender. If we run the query, then of course we created the student. So if we show the description, so description of the student database table, then of course we have an ID as a primary key with auto increment feature. We have a varchar student name, and we have a gender as an enum with 2 possible values, male and female. Okay, so what if we would like to insert, so insert into the student database table as far as the values are concerned, and of course we have to define the student name we would like to insert and the gender, and the values will be, for example, Adam, so Adam, and of course it will have the value male. Then we have Kevin, of course again with male. Then we have Anna with female, of course. So let's see whether it is working fine or not. So if we run the query, then it is working fine. So show everything as far as the student database table is concerned. If we, sorry for that, not show, but select. Okay. If we run the query, then as you can see, we have managed to insert male and female values. What if we would like to insert So we use insert student name, gender, values, for example, Joe, as far as male is concerned. In this case, we are not able to execute this operation because, of course, male is not a categorical value as far as the gender enum is concerned. So we have to use capital M or capital F accordingly. And what if we would like to select everything from the student? So if we use something like this, then of course we select every single student, but we can say that where the gender is equals to male. So if we use something like this, then of course we select all the male students. And by the way, under the hood, MySQL is going to represent enums with the help of integers starting with 1. So if we have, for example, 3 categories, for example, low priority, medium priority, and high priority, then we have the values 1, 2, and 3. Which means that because enums are represented as integers, we can sort the enum types. So we are going to talk about how to order the given data set, so how to sort the underlying items, and we will come to the conclusion that we can sort enum types because MySQL assigns integer representations for the given categorical values. Okay, by the way, using enums is not always the best solution possible because enums are not SQL standard, which means that not all of the database management systems can handle enum types. But anyways, this is how we can define a gender as an enum with 2 categorical values, male and female. Thanks for watching. In this lecture, we are going to talk about Boolean values. So first of all, there are no real Boolean values when dealing with MySQL as a database management system, because Boolean is represented by a tiny integer with a single digit. So MySQL assigns integer values to Boolean variables. The false value has the integer representation 0, and 1 or any other value is representing the true Boolean value. So let's take a look at a concrete example. We can create a table with the name, for example, process. Of course, we can define the given variable. So we have a given ID. It is an integer, primary key. So this is the primary key and auto incremented. Okay, then we have a given process description. It is a varchar. And finally, we have a Boolean variable, whether the given process has been completed or not. And maybe this process is a built-in variable, so let's use the task as the table name. So we have the completed, which is a Boolean value. Okay, so if we use something like this, let's create the database table. As you can see, we have managed to create the database table. So if we describe the task as a database table, then of course it is going to work just fine. So we have 3 columns, an ID that is a not null primary key with auto increment feature, we have a process description, and we have a Boolean column whether the given task has been completed or not. So let's see what's going to happen if we insert into the task database table as far as the process description and as far as completed is concerned. So what do we have to do? We have to insert the values. So we have processing the artificial intelligence data, something like this. And of course, we have a given Boolean variable, whether it has been completed or not. So for example, it has the value false. Then we have another value, so let's use something like this, maybe a bit more straightforward what's happening under the hood. So we use something like this, handling database related issues or something like this, and it is completed. So what's going to happen if we save and run the query? Then as you can see, it is working fine. So if we select everything from the task database table, then we can check the content, and as you can see, these Boolean variables are transformed into integers 0 and 1. So 0 is going to represent false value and 1 is going to represent true value. So we can get, for example, select everything from the task database, and we have a where clause. We are going to talk about the select statement and the where clause, but of course, in order to check whether the Boolean values are working fine or not, we have to use these keywords. So what's crucial that we can check whether the completed column is true or not. So in this case, completed is equals to true. It means that the value is equals to 1. So if we save and run it, then as you can see, just the row is going to be returned where the completed variable is equals to 1. So MySQL handles Boolean values as tiny integers. And of course, if we insert into the task database table as far as process description is concerned, and as far as completed variable is concerned, we can insert the values, for example, learning MySQL or something like this, and it has the value 2, then what's going to happen? Of course, it is going to work just fine, so we can select everything from the task database table. So if we save and run it, then as you can see, 0, 1, and 2. We have been talking about that the 0 value is false, and all the other integers are going to represent true values, despite the fact that in this case we have 3 possible values, while Boolean values can have 2 values, true or false, 1 or 0. So this is what we have been talking about, that 0 represents false and 1 or any other value represents true. Which means that if we select everything from the task and where the completed is true, then of course the row with the third ID is going to be returned as well. So as you can see, all the values that are greater than 0 are true basically. So this is how we can handle Boolean values in MySQL, because there are no Boolean values at all. We are dealing with tiny ints, so single digit integers. And of course, the false value has the integer representation 0, and any other value are going to represent the Boolean value true. Thanks for watching. In this lecture, we are going to talk about how to handle floating point numbers with the help of decimals. There are 2 parameters as far as decimal values are concerned. The precision, which is the total number of allowable digits. So for example, in this case, we have 1, 2, 3, 4, 5, and 6 digits altogether. And we have S, that stands for the scale, that is the number of allowable digits to the right of the decimal point. So this is the fractional part basically, with 1, 2, 3, 4, and 5 digits. So we have the integer part, in this case 2, and we have the fractional part 7, 1, 8, 2, 8. So let's create another database table. So create table, for example, circle. And as far as a circle is concerned, we are going to have a given ID. So it is an integer primary key auto increment feature. Of course, we will have an x coordinate that's going to be a decimal. And here we can define the scale and the precision. So for example, we are dealing with 19-digit values where the fractional part is equals to 8. So what does it mean? For example, if we have something like this, 8 and 5, it means that basically we can have 8-digit values. So for example, 1, 2, 3, 4, 5, 6, 7, 8. And the value 5 means that the fractional part consists of 5 digits, 1, 2, 3, 4, and 5. So we will end up with something like this. We have 3 digits for the integer part and 5 digits for the fractional part. And of course, if we sum up 5 plus 3, it is equals to 8. If we have, for example, 10 and 6, then of course we will have 1, 2, 3, 4, and then we have 1, 2, 3, 4, 5, and something like this, which means that there are 10 digits altogether, and there are 6 digits after the decimal point, 1, 2, 3, 4, 5, and 6. Okay, so this is how we can define decimal. Usually we use 19 and 4, which means that we can represent 19 digits floating point numbers, where 4 is equals to the number of digits after the decimal point. So we can use something like this and it is going to be just fine. We have y as the coordinate, so it is going to be a decimal 19 and 4 as well. So in this case, we have a given circle with two coordinates, x and y. We can define not null, so something like this is going to be just fine, and it is working fine as you can see. Okay, so what do we have to do? So first of all, we can describe the circle table. So if we run the query, then as you can see, we cannot have null values because ID is the primary key and we have x and y coordinates with decimal values. So for example, if we insert into a circle database table, as far as x and y coordinates are concerned, the values, for example, we have 2.1234 and we have 4.23. It is going to be the x and y coordinates for the first cycle. Then we have, for example, 122.134. Then we have 1789 and 2 and we have, for example, just 1. So if we use something like this, it is going to work just fine. So if we select everything from the circle database table, then of course it is going to work fine. So as you can see, no matter what values we have inserted, there's going to be 4 digits after the decimal point. So we have 1234, 2300, 1340, 1000, because we have defined the decimal values as 19 and 4. So there are 4 digits after the decimal point. Okay, so what if we would like to insert a value outside the scope of that given range? So for example, we insert 1234999, something like this. As you can see, there are more than 4 digits after the decimal point. Then of course there's going to be a value that data truncated. So basically MySQL is going to truncate the value. So if we select everything from the circle database table, then we can come to the conclusion that the values have been truncated because we are able to store floating point numbers with 4 digits after the decimal point. Okay, so this is how we can handle decimal values. In MySQL, the precision must be smaller than 65 and the scale should be smaller or equals to the precision. So this is why we can represent floating point numbers with at most 65 digits. If we are not bothering with the decimal point, because of course the precision is the total number of digits, no matter we are dealing with the integer part or the fractional part. So that's all about floating point numbers. Thanks for watching. In this lecture, we are going to talk about how to handle date and date time. So first of all, let's create a table. So let's create table, for example, data example. It is going to be the name of the database table. We are going to define an ID that's going to be an integer, and we are going to define a simple date. For example, the date variable is going to be a date, and we are going to be a date time as a new date time. So let's see what is the difference between the two entities. If we run this query, then of course it is going to work fine. So first of all, let's describe the data example. As far as this database table is concerned, we have a given ID that is an integer. We have a data that has type date, and we have a date time variable that has the type date time. So let's try to insert. So insert into data example, and for example, let's insert 1 as the ID, and we can use the so-called now function. We are going to talk about functions in the coming lectures, and it is going to be clear that what is a function. What's crucial that the now is going to return with the actual date. So if we use something like this, then we can check what is the difference between date and date time. So if we run this query, then it is going to work fine. And if we select everything, so if we get the content from the data example database table, then let's take a look at the result. As far as date is concerned, as you can see, the date has something to do with the actual year, the month, and the day. As far as date time is concerned, we have the year, the month, the day, we have the hours, minutes, and seconds. So this is the crucial difference between date. Of course, if you are not interested in the hour, the minute, or the second, then of course you have to use date as the type of the column. If the hour, the minutes, and the seconds are crucial, then of course we have to use a date time as far as the type of the given column is concerned. Of course, if we want to insert a new value manually, so insert into the date example the values, okay, and let's define the values manually. What about the integer ID? It is going to be 2. What about the date? Of course, we can define a date without any problem. For example, 2005, for example, July as the month, and for example, the day is equal to the 17th. So this is how we can define a given date as far as the year, the month, and the day is concerned. And of course we have to use the string format, so we have to use something like this. What about the date time? As far as the date time is concerned, we have to define the hours, the minutes, and the seconds as well. So for example, 2018, January the 5th, for example, and of course we have to define the hour, the minute, and the second. For example, 7 a.m., the minute is 12 minutes, and for example, 45 seconds. So we have to do something like this if we run the query. And of course, sorry for that, because the name of the database table is, you have to make sure that you use the valid name of the database table. Okay, so it is working fine. We have managed to insert these values, and if we select everything, so select star from the data example database table. So if we run this query, then as you can see, we have managed to insert the second example, 2005, the 17th of July, and we have managed to insert a date time manually, the 5th of January 2018, and this is the time, 7 a.m., 12 as the minutes, 45 as the seconds. So this is how we can handle dates and date times. Thanks for watching. In this lecture, we are going to talk about the solution for the exercise. So what do we have to do? We have to create a database table with name employee. So we have the employee table. Okay, and what do we have to do? We have to define an ID that's going to be an integer. We have to define an employee name that's going to be a variable length string, so a varchar basically. So varchar 30, okay. Then we have to define a fixed length string for the nationality. So we have a nationality with 3 characters. And then we have an enum, so basically a categorical data, whether the given employee is a standard employee, a manager, or a CEO. So we have the employee type as an enum with employee, with manager, and CEO as the categorical values. So that's all about the standard employee database table. So if we run the query, then it is working fine, as you can see. So let's see the description of the employee as the database table. So if we use something like this, then as you can see, we have the ID, the employee name, the nationality, and the employee type. Okay, after that we come to the conclusion that the ID must be an auto-incremented primary key. So what do we have to do? We have to use alter table as far as the employee database table is concerned, and I would like to modify the ID column, and I would like to set it to be an integer, a primary key as far as the auto-increment feature is concerned. So it is going to work just fine. If we run the query, then we have managed to update the employee table. So as far as the description for the employee table is concerned, if we rerun, then as you can see, the ID has become a primary key with the auto-incremented feature. Okay, then we come to the conclusion that we would like to have an additional column for the gender. So what do we have to do? Alter table employee odd column. It is going to be a gender, an enum with 2 categorical values, male and female, and we can define that where we want to insert that given column. For example, we would like to insert it after the employee name. So after employee name, it is going to work just fine. So if we do not specify after employee name, then it is going to be the last column of the database table. But of course, we can define where we want to insert that additional column. So we modify the employee table, add an additional column named gender with enum male and female after the employee name. So if we run the query, then it is going to work just fine. So if we describe the employee table, then what's going to happen? So if we run this query, then ID we have the employee name, and right after the employee name we have a gender that is an enum. We have a nationality, we have an employee type. So after that we would like to insert into employee as far as the employee name, the gender, the nationality, and the employee type is concerned, with values going to be the Adam, for example, the gender is going to be male, nationality is going to be USA, and the employee type is going to be a standard employee. And of course we have to do several out of these. So for example, I would like to insert 5 entries. So we have 5, and we have Kevin. It is a male as well from Argentina, and it is a manager. Then we have Joe. It is a male as well from Hungary. It is a standard employee. Okay, we have Anna, of course a female from the United States of America, and she's the CEO. And we have, for example, Michael. It is a male from Germany, and he's a manager as well. So if we run the query, then it is working fine. So we can select everything from the employee database table. So if we execute this order, then of course we have Adam, Kevin, Joe, Anna, and Michael. Male, 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 female, and male. The nationality can be the USA, Hungary, Germany, and so on. And we have the employee type, standard employees, managers, or the CEO itself. So what if we would like to remove, so delete from employee database table where the nationality is equals to USA? So this is how we can get rid of all the employees where the nationality is equal to the United States of America. So if we execute this statement and then we select everything from employee, then of course the result is going to be Kevin, Joe, and Michael. So basically we have managed to get rid of all the items where the nationality is equal to the United States of America. So this is how we can solve the exercise. These are the topics we have considered in the previous lectures. Thanks for watching.